Good evening. I'm just getting the screen set up here for us. Excellent. Okay, my name is Elisa Meyer. I am in Biochemistry 1, Course 316, and this is my final project with the chapter overview. The first chapter we will be going over is Chapter 14, Carboxylic Acids and Carboxylic Acid Derivatives. Carboxylic acids are very popular compounds. This is due to the carboxylic group, which consists of two very polar function groups, the carbonyl group and the hydroxyl group. The carbonyl group of the ester is polar and can be participated in dipole-dipole attractions. However, the carbonyl group is flanked by hydrocarbon chains. The polarity of esters is comparable to that of aldehydes and ketones. In fact, esters boil at approximately the same temperatures as aldehydes and ketones of comparable molar mass. In the bottom right-hand corner, is a structure of an ester. For an example, the subcategory of this chapter is a nomenclature, which are esters of our carboxylic acid derivatives, organic compounds derived from carboxylic acids. As shown in the general reaction equation above, the picture that we saw, they are formed from the reaction of carboxylic acid with an alcohol, and both of these reactants are reflected in the naming of the ester. The simplest method to name an ester begins by recognizing the carboxylic acid and alcohol from which it is composed. This can be done by inspection of the structure. Another subcategory was acid chlorides, which are carboxylic acid derivatives having the general formula. They are named by replacing the "ic" at the end of a common name with "eel" chloride, or the oic acid of the IUPAC name of the carboxylic acid with oil chloride. Acid aldehydes are molecules with the following general formula. There was an illustration that I did have on here, but it will not show up, so I apologize. Another subcategory is acid anhydrides, which are molecules with the following general formula. The name of the family is really quite fitting. The structure of an acid anhydride reveals the acid anhydride are actually two carboxylic acid molecules with a water molecule removed. The word anhydride means without water. So between these subcategories, we're just seeing how they differ. Moving on to Chapter 15, amines and amides. Amines are organic derivatives of ammonia, and like ammonia, they are basic. In fact, amines are the most important type of organic base found in nature, so they're the basis of everything, and as mentioned, the most important. We can think of them as substituted ammonia molecules in which 1, 2, or 3 of the ammonia hydrogens have been replaced by an organic group. And then we can refer to the illustration here in the center, the ammonia and amine, where the R substitute takes place for the hydrogen. Amines are classified according to the number of alkyl or aryl groups attached to the nitrogen. Amides are the products formed in a reaction between a carboxylic acid derived and ammonia and or amine. The general structure of an amine is shown here. Of an amide is shown here. Most amides are solid at room temperature. They have very high boiling points, and the simpler ones are quite soluble in water. Both of these properties are a result of strong intermolecular hydrogen bonding between the nitrogen and the hydrogen bond of one amide and the CO group of the second amide. Chapter 16, carbohydrates. This one was one of my favorites other than fats. This one I found quite interesting because what I've learned between carbohydrates and fats is that until taking biochemistry and simply focusing on them from a physical or a nutritional perspective, a lot of people that don't have this knowledge, including myself before this, really misunderstood both carbohydrates and fats and how they work. So I'm excited to have learned all of this. Carbohydrates produced in plants by photosynthesis, something that we learn back in biology. Monosaccharides, disaccharides, glucosidic bond, oligosaccharides, and polysaccharides are a few of the categories. Monosaccharides are composed of carbon, hydrogen, and oxygen. They can be classified on the basis of the functional groups they contain. So this is basic information that we've learned in our general chemistries as well as biologies. A monosaccharide with a ketone, carbonyl group, is a ketose. So that's interesting because a lot of people now are into the ketone diet. So to actually understand how that happens on a chemical level has been really interesting. In a ketose, the carbonyl group is located on carbon 2. If an aldehyde or a carbonyl group is present, it is called an aldose. And then the bottom right picture are examples of some carbohydrates, the breads, fruits, and vegetables, pastas, and starches. They are simple sugars, but those simple sugars can cause tooth decay. This is just a random fact. Stereoisomers are the completion of simple sugars, so monosaccharides, and glucose is the most important sugar in the human body. It is found in numerous foods and has several common names, including dextrose, grape sugar, and blood sugar. Glucose is broken down in glycolysis and other pathways to release energy for body functions. C6H12O6 is glucose, and it also has many other types of functions. Moving on to my second favorite, lipids and their functioning, from chapter 17. The term lipid actually refers to a collection of organic molecules of varying chemical composition. They are grouped together on the basis of their solubility in nonpolar solvents. Lipids may be subdivided into 4 main types. This is directly from the book, these 4. Fatty acids, so your saturated and your unsaturated. Glycerides, so glycerol-containing lipids. Non-glyceride lipids. Steroids, waxes, and sphingolipids. Complex lipids, so lipoproteins. As a result of the many different types of lipids above that we listed in their biological function and processes, these are some examples from the book, again, of all the things that those 4 categories can do. They serve as an energy source, energy storage, cell membrane structure components, hormones, which are critical to chemical messengers. They serve for vitamin absorption of A, D, E, and K. They serve as protection to bones and organs, but too much can be harmful to both bones and organs. And they serve as insulation. Fat that is stored beneath the skin serves as insulation to the body. Both carbs and fat work together to create, or when oxidized, to create energy for the body, releasing 9 kilocalories of energy per serving. And then these are my sources listed. I used the book, Chem.LibText, that's where I just got a few few different random facts, and then Khan Academy gave an overview of the last chapter with macromolecules and lipids to help bring them together and help me better understand. Thank you so much for a great quarter. I hope that you have a wonderful break, and Merry Christmas.